Okay, today we begin the fundamental theorem of calculus. This is a huge theorem of calculus that we're going to use time and time again. It's a way of figuring out the exact area underneath a curve. So we're going to do that through integration and bounds. So if we're going to find the area underneath a curve on the closed interval from A to B, we are going to find the integral of this, the antiderivative. We're going to plug in B first, then we're going to subtract the antiderivative of the value A. Make much more sense once I do a problem. Basically, all you're going to do is you're going to integrate this, you're going to plug in B, and then you're going to go minus, you're going to plug in A, whatever you get for your integral. So the first thing I'm going to do to introduce this is it says use a graphing calculator, and you guys can go ahead and get out your graphing calculators. And all we're going to do is determine if the area underneath the curve is positive, negative, or zero. We're not going to compute the exact area. This is just to figure out if it's positive, negative, or zero. So if you would go ahead and graph on your graphing calculator the cosine of 0 or the cosine of x, you will find that your graph looks like this from 0 to pi. So from 0 to pi, it would go up at 1, it'd come down here, and then it'd finish at negative 1. So you'd be talking about the area underneath the curve here and here. Knowing what we know about cosines and sines, we know that these two areas to be exactly the same. This one above the curve is positive, and this below the curve is negative. So therefore, since these are the exact same areas, then we'd be taking maybe this is 5 and this would be negative 5, and adding those together, we'd end up with a 0 for our area underneath that curve. This next picture, if you go ahead and graph it on your graphing calculator, you will see that it looks something along these lines. And we're talking about the area underneath the curve from negative 2. I've got this spread out a little too far, so let's see if I can fix this, make it look a little bit better, a little bit more like what the curve looks like. So it goes something like this. There we go. So we're going to talk about the area underneath the curve would be here. This would definitely be negative area. It's underneath the x-axis. And here we would have positive area, but we'd have a lot less positive area than we would negative area. Therefore, we know this answer would be negative. Alright, now we're going to actually use the fundamental theorem of calculus, and in order to do that, what we want to do is we want to integrate what is given here. So I'm going to go ahead and integrate this first. So I'll have 6x to the third over 3 plus 2x to the second over 2 minus 3x. I don't need to put plus c's because I'm talking about a definite integral and we're going to be using bounds. We only put the plus c's on indefinite when we're not sure where we're taking the area to and from. This does reduce, so I'm going to go ahead and do this first. And I end up getting, this is my integral, and we're going to go from 1 to 7. Well, when I plug in, because what I'm supposed to do is I'm supposed to plug in b first, b and then minus a. So we're going to have 2, and then I have 7 cubed, plus 7 squared, minus 3 times 7. This is all my first integral with the 7 plugged in. Then minus, you're supposed to do the same thing. Take the integral and plug in 1. Then you just simply figure out what each of those numbers are. I would simply put it in my calculator and let it compute. I can do a few of these pretty quickly. 7 to the third power, I don't know what that is off the top of my head. I could put that in real quick. 7 times 7 would be 343 times 2 would be 686. So 686 plus 49 minus 21, and then we have 2 plus 1 minus 3. When you compute this to be, your final answer would be 714.